behind it. Hey, more people. Oh. Okay. Oh, Justin's in. What's up, buddy? Nope. Don't want to do that. Hold on. I am just clicking buttons.
This is actually Nicole. I'm on my boyfriend's computer and I don't know how to change the name.
That's okay. That's okay, Nicole. I understand. I've had that issue already this semester with Zoom. Okay, let's get rocking and rolling. Before we start, I want to go over tomorrow. Tomorrow we will not have Zoom class. Okay, it is. I have to be in a conference all day. I believe I told you this maybe Monday or Tuesday. I have to be in a conference all day. I will have a lecture put in to Blackboard after today for that Thursday. So for tomorrow's class, and you'll see it. It's 2.2. I think it says something like 2.2, 2.2 and 2.6, something like that. I don't know. I know I've got it set up correctly. It'll be in there later today or tomorrow morning, or by tomorrow morning anyway. So just watch that, and then Monday when we get back, we'll just keep on keeping on. Do you guys have any questions on Brianna and Nicole? Do you guys have any questions about homework?
I didn't know if it was gonna be like the first one that I was in and just having tests every day, or if we actually had homework this time.
Well, I mean, I gave you homework. Did you watch the video yesterday? Did you watch the lecture?
No, I have not had internet for the past 2 days either.
Okay. Well, that's fine. Go back and watch those lectures, and then you'll see. No, I just assign homework.
Okay.
So I assign homework in the book, and then you just do it, and then that's what really your points are all from test. Go back and watch those now that you've got the internet back. Okay.
Okay.
Because I go over an introduction of the class and the structure, and then I go over the first lecture, which was yesterday.
Okay.
Okay, sweet. Let's get going. Wait, Nicole, what's your last name?
Golden.
Okay, yeah. Did I have you last in the first 7 weeks?
Yes.
Okay, yeah. It's set up very similar to that. Very similar.
Okay.
But just make sure to watch those because it is a little different because it's college algebra.
All right.
Okay, 2.1. Today we're going to go over functions. Now, I teach these like you've never seen this before, but again, a lot like 1.5, like the last lecture, it should be a review. You should have seen these at some point in the past, but I do go over them as if you kind of have it. It's a very kind of basic lecture, actually. So before we talk about functions, we have to talk about relations, not relationships. That is not this class, okay? A relation, the way your book defines it, is any set of ordered pairs. Okay, so I don't like that. I don't like that definition, but I'm going to roll with it. Any ordered pair. Now, what's important though with any ordered pair though is the first component is called the domain. So the first component is the domain. And the second component is called the range. So I assume you've heard those names before, but we're going to talk more about domain and range a lot today. Okay. So a relation is just any set of ordered pair with a first component that's a range and second component, or I'm sorry, first component is the domain and second component is the range. So here's what we're going to do today. Let's talk about just a basic relation. This is kind of, sometimes these are called bubble graphs or circle graphs. And it'll be nice that we only have like 3 or 4 people here. Everybody will get to answer this question. So here's a relation. So let's draw 2 bubbles. And the first, we're going to call this the student. And then I want you to tell me, let's say the pet you own, or pets, like types of pets. So type of pet. Now by type of pet, I mean like dog, cat, lizard, fish, whatever it is. So you guys, Nicole and Brianna, just type it in chat, and I'm going to put down. So do we have all different last names? Yes. Okay. So Janie, what you got? Janie's got a cat and a toddler. I'm just going to put the cat. So Janie's going to go to cat. Right? And then Nicole, same thing. Okay. Brianna. Waiting on you. Here, I'll go to me. Me, I've got a dog. If Brianna doesn't answer, we get to make up Brianna's. A dog. Okay. Okay. This is an example of a relation. Okay. I'm going to make up one other person. Let's say this other person, Heather, making her up. Let's say she doesn't have a pet. Okay. So she's just hanging out there. But so for relation, you need an ordered pair. Okay. So we're going to make up that, okay, Heather, we're going to force her to have something. Let's say she winds up having a dog and a cat. Okay, she's got a dog and a cat. So Jane's got a cat. Nicole's got a cat. Brianna's got a dog. I've got a dog. And then Heather down here is a cat and a dog. This is a basic relation, okay? This first group is called the domain. This second group is called the range, okay? You could write these as ordered pairs if you want. It's kind of goofy to do it with letters and not numbers, but you could. I mean, I'll just, like for Janie and Cat, you could write this as J, Cat, right? That would be the ordered pair. And then Nicole, Cat. Brianna, dog, and so on. Okay, you could write these as ordered pair. That first group is always called the domain. Second is the range. Now, if the book or I ask you to give me the domain and range, we write these as a set notation. You know, we talked about interval notation yesterday. Well, set notation is when we have like kind of more than one answer, but it's not continuous. It's not like X is greater than 5. It's just that we have 1, 2, 3, 4, 5 different students. So if I asked you to list the domain, I'll try to write it in over here. If I asked you to list the domain, you would use squiggly brackets, and it does not have to be in order because order isn't important here, right? I mean, it doesn't matter what students listed first, but it would be Janie, Nicole, Brianna, Robert, and Heather, right? That would be the domain. The range, though, would be cat, really just cat and dog, right? Now, we wouldn't repeat like, because cat's like used 3 times, we wouldn't say cat, 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 right? Even though Janie, Nicole, and Heather had a cat, you would just say cat and dog. Those are really the 2 options for domain, okay? This makes sense. Questions about this? It's kind of goofy. I mean, it's a fun example. I get to find out what kind of animals you have, but also this is really kind of the basics before we get into the like formulaic stuff with relations. Okay. Then next we've got functions. So now we're going to lead. This is going to lead us into functions. Now functions are a special relation in which the domain, like for this last example, like each person's domain goes to 1 and only one output. Not output, sometimes they're called the output, but one and only one range. Okay, one and only one range. So it's a special relation in which the domain goes to one and only one range. So we're going to do a fun one here because I love talking about food. And I'll tell you, part of doing the Zoom thing and not having many students in class, I feel like I don't get to talk about everybody's favorite recipes on everything. And that is one of my favorite goofy things to talk about. So I'm going to do the same bubble notation. So we've got students. And I want you, and you guys, Brianna and Nicole, just tell me in the chat. I want you to tell me your favorite breakfast food. Favorite breakfast food. Okay. I need your favorite breakfast. Janie, what is your favorite breakfast food? French toast sticks? Oh, yes, that sounds awesome. Okay, I'm going to shorten it to French toast sticks, FTS. Okay. So Janie, favorite breakfast food, French toast sticks. I'm going to tell you mine while you guys, Brianna and Justin, or not Justin, but Nicole, while you're thinking about this. Mine is biscuits and gravy. BG. Oh yeah, that's my favorite. Hash brown bowls, heck yes. Nicole, hash brown bowls, HBB. Okay, Brianna, it's on you. Favorite breakfast food? I'm going to say Heather down here is also, her favorite thing's French toast sticks as well. I'm making up Heather. Okay. Waiting on you, Heather. Or on Brianna, not Heather. Heather's your mom, right? And this is still our domain. And this is still our range. Brianna, are you there? I need your favorite breakfast food, or I'm going to make up your favorite breakfast food. She doesn't come on. I want to tell, but while she's thinking, I also want to tell you a few things. Sometimes this domain is called the input, and this is the output. We'll get to that really in the equations here in a little bit on why that's true. But sometimes the domain is called the input, range is output, and then also domain is sometimes called the independent variable. And then this is the dependent. And we'll get to why here in a minute. Okay. I'm going to make one up for Brianna since she's taking too long. I'm going to say Brianna's favorite breakfast food. This is a total guess, are pancakes. We'll go pee for pancakes. Okay. Okay. Now, look, same thing. This is still a relation. We've got a domain and range. Each person chose something. And if we wrote these out, it'd be like J, FTS, R, BG, N, HBB, Brian, B, pancakes, and then Heather also FTS. Now, here's the thing, though. The reason this is a function is because each one of us chose exactly one breakfast food, okay? Each one of us chose one and only one breakfast food. If we go back to the example before about the type of pet, notice you can own more than one pet. I mean, Heather down here owned a cat and a dog. That's not weird, okay? So because of that, this relation is not a function. The type of pet you own is not a function because you can own more than one pet, okay? Like, I mean, and I do this example every semester, this one, and I believe I'll get students that have, a dog, cat, lizard, fish, and it's like extreme kind of like, yeah, they own a lot more than one. So this example of a relation is not a function because you can own more than one pet. But the example of favorite food or like favorite color or something like that, you can only have one of those. So therefore, those wind up being good examples of functions. Each person goes to exactly one breakfast food, favorite breakfast food. Okay, great. Sure, I'm not skipping anything before I go on. Okay, now let's look at this actually as numbers, as ordered pairs. Okay, remember your book really defined it as an ordered pair, the relation. So if we look at these as ordered pairs, we need to look at the x values. So if I gave you some group of ordered pair, let's say 2, 1, negative 3, 4, 7, 2. Okay. I just gave you some group of ordered pair. And I'm going to ask you, hey, is this group of ordered pair a function or not? Okay. Is it a function or is it not a function? And you can think of the bubble here, right? In the bubble, if you go back to the bubbles, the x values, are our first values. They're our domain values. So we've got 2, negative 3, and 7. Well, each one of those goes to 1 and exactly 1 output. Like I'm going to add another coordinate here just for fun. Let's say I had 3, 1. Still a function, right? And the reason, the kind of quick, easy way to notice, the easy reason to kind of see that this is a group of functions, or not a group of functions, this is a function, is that the x value does not repeat, okay? So this is a function. This is a function. Because the x values do not repeat, okay? But if we think of the bubbles here, we'd have what? 2, negative 3, 7, and 3. And each one of those bubbles will go to actually 2 goes to 1, right? That's fine. Negative 3 goes to 4. 7 goes to 2. And 3 goes to 1. That's fine. Look, all 4 of these go to 1 and only 1 y value. Now, the 2 and 3, they have the same y value. That's fine. That's just like down here when Janie and Heather both chose French toast sticks, okay? That's not a big deal. It's just that neither one of them could choose French toast sticks and biscuits and gravy, right? Janie can say, oh, my favorite breakfast food is French toast sticks and biscuits and gravy. That would make that not a function, okay? That would make that not a function. Okay. So let's look at what this looks like on a graph. Just to get a refresher on graphing, if we haven't seen it in a little bit. We got X, we got Y, and I'm going to just graph each one of these points. Now, I go all the way to 7 here. So 1, 2, 3, 4, 5, 6, 7, 8. How far down do we go? Well, we don't go down at all. To the left, we go to negative 3, 1, 2, 3. And we go up 4. 4. Okay. So 2, 1 is right there, right? That's our first coordinate. Negative 3, 4 is right there. 7, 2, 1, 2, 3, 4, 5, 6, 7, and up 2 is right there. And then 3, 1. 3, 1 is right there. I think that's all 4 parts, right? 2, 1, negative 3, 4, 7, 2, and 3, 1. So there's all 3 coordinates. And now look, notice these are not connected, okay? They're not connected because all I did was give you 4 distinct coordinates, okay? If we were going to connect these, we would need like an equation or something like that to move forward. But look, check this out. This leads me in kind of, I don't follow the way the book kind of goes over this because I believe all these topics need to overlap. But look, this leads me into the next example. Look, notice none of these coordinates are on top of each other. If we had a repeating value, let's say 3 went to 1 and it also went to 2. You would have 3, 2 right here. And you'd have a coordinate on top of each other. It leads us to the vertical line test, okay? What the vertical line test says is, look, if you're given a graph, if a function will never have another coordinate on top of itself. So it's never going to cross the vertical line, like an imaginary vertical line, more than once, okay? I'll go over an example of where this is violated. It'll make more sense coming up, okay? Like I'm going to do that down here, actually. So let's look at another example. Let's say I gave you one that is clearly not a function. Let's say negative 1, 3, 2, 4, and negative 1, negative 2, okay? Negative 1, 3, 2, 4, and negative 1, 2. Now, so first off, this is not a function. not a function, x equals -1 repeats, okay? If we think of it as a bubble, now I'm running out of space here, but see if I can pull this off. If I think of it as the bubbles, as the domain and range bubbles, -1 goes to 3, right? 2 goes to 4. Oh, but -1 also goes to -2. Okay? Notice this -1 goes to 2 y values. Hey, that's not a function because -1 can, these domain values are only supposed to go to 1 y values. It's still a relation. It's a group of coordinates, right? But it is not a function. Okay, not a function. This value goes more than once. And check out the graph on this. Okay, so we've got -1, and it goes 2, 3, 4. So -1, 3, 2, 4 is up here somewhere, and then -1, -2. Notice on the graph, if I drew, now this is kind of an imaginary vertical line. I'm going to use, I don't know why I chose 2 green markers today, but I'm going to draw an imaginary vertical line here. Notice it crosses twice, okay? This imaginary vertical line crosses at x equals -1. It crosses at 3 and -2, right? So because it crosses twice, we can also see if I just gave you a graph that this would not be a function, okay? Not a function because this would be called, it fails the vertical line test, okay? At -1, you can even say at x equals -1. Fails the vertical line test. Now over here, notice if I drew imaginary vertical lines at every single one of these coordinates, there's not going to be another coordinate that overlaps the vertical lines except the ones that are given, okay? Those are the only ones. Well, over here, that's not true. It overlaps twice, right? So therefore, it fails the vertical line test. This is a great example of not a function, okay? This thing is not a function. Questions about this? Now, because these are coordinates, we're about to get into equations, okay? So coordinates and equations are going to look different. They're going to look different on a graph, and they're definitely going to look different as we go along here, testing to see if we have functions or not. Okay, so let's switch over to equations now. We're going to determine if equation's a function or not. We're going to do it a few different ways. The book, I believe, starts with oh yeah, I don't really like the way the book does it. We're going to do it a little differently. But so now we're going to give it an equation. Give it an equation. So give it an equation. Determine if it's a function. I'm going to go over 2 ways to do this, okay? 2 ways to determine if an equation is a function. And let's start with one that's not a function. It's kind of easier to see when they're not a function. I'm going to do an absolute value graph. So if you're not familiar with absolute value, sit tight and you'll be fine. So the absolute value of y equals x plus 3. Okay? The absolute value of y equals x plus 3. So the way this works, and remember a few pages ago, I told you that the domain value can also be the input value. Well, that means the y value is the output value. We're going to utilize that kind of notation now, input, output. And what we're going to do is we're going to input an x value. So you can kind of choose any x value. Absolute value, you got to be kind of careful because we know absolute values only produce positive numbers, okay? So I'm going to be careful when I choose an x value here, but you can really choose any x value that works correctly with the equation. So I'm going to choose an x value of, let's say, 2, okay? And I'm going to input it into this equation. And if I did that, I would get the absolute value of y equals, well, 2 plus 3 is 5, right? The absolute value of y equals 5. Now, I have to think, if you don't know much about solving absolute values, if the absolute value of y equals 5, what can y be? what can I take the absolute value of and get 5? And this is going to be our output. Well, I know the absolute value of 5 is 5, right? But also the absolute value of -5 is also a +5, right? If I put -5 in there, the absolute value of -5 is 5, right? And the absolute value of 5 is 5. So look, notice I put one input value, x equals 2, but it goes to 2 different y values. Hey, hold on a second. We know this means that's not a function. Because if I put in a single domain value and it goes to 2 different y values, we know if we graph this, this is not a function. So that's how you test it. If you plug in an input value, the domain value, single domain value, and you get back more than one output value, more than one y, not a function. Okay, not a function. Okay. Now I'm going to graph this thing, and all I'm going to do is start choosing coordinates to graph it because I don't know what it really looks like. I mean, I do, but we're going to act like I don't. Okay. So I know 2 coordinates already, right? I'm going to write these down here. I know that 2, 5 and 2, -5 are coordinates, right? So let's plug in like what if I plugged in x equals 0? That's always kind of nice. If I plug in x equals 0, I get the absolute value of y equals 3. Oh, well, that tells me y equals 3, but y could also equal -3. So 0, 3, 0, -3, right? So let's plug in like, let's say -2. If I plug in -2, I get the absolute value of y. -2, I get a +1, right? So I'd get back y equals 1 and a y equals -1. So at -2, I'm at +1 and I'm at -1. And now look, I can plug in -3 and I would get the absolute value of y equals 0, right? -3 plus 3 is 0. Well, absolute value of y equals 0, y can only be 0 here. So -3, we're at 0. Now look, check this out. I can't plug in a more negative number here. Because if I plugged in like -4, I'd get the absolute value of y equals -1. We can never take an absolute value and get a negative. Okay, so it stops. So I know the graph kind of stops there. So let's see what this looks like when I graph it. They go to -3, 1, 2, 3, to what, +2? At +2, I'm at 5 and -5. 1, 2, I'm at 5 and I'm at -5, right? Right there, this tells me this isn't a function. Remember, if I drew a vertical line here, it crosses more than once. At 0, I'm at 3 and I'm at -3, right? At -2, I'm at 1 and I'm at +1. I've got like a funnel going on. And at -3, I'm at 0. That's exactly, I've got a sideways V is actually what I have going on. That's what this graph looks like. Now this one I'm going to connect the dots because it's an equation, okay? This is an equation, and what that means is we have the dots are connected, okay? The dots are on the line and they are connected. Okay? Now notice, if you look at this graph, let's say I didn't do any of this stuff and I gave you that graph, okay? And I made you look at this graph and ask you, hey, is this graph a function? If I draw a vertical line anywhere other than this one point at the end, if I draw an imaginary vertical line anywhere, I'm just going to draw it right here. Why not? You'll see it crosses more than once, right? It crosses 2 times. And because it crosses more than once, not a function. This thing is not a function, okay? Now on the test, it's going to be a little more basic. I'm just going to give you an equation and say, is this a function or not? But you have a few different ways to test it now. You can plug in an x value, see if you get back more than one y value. You could graph it if you wanted to, like choose coordinates out and then graph it and see if it passes a vertical line test, okay? Or, I mean, you could have made bubbles out of these coordinates too if you wanted to, and see that 2 went to 5 and -5, 0 went to 3 and -3, and definitely not a function. 3 different ways we know this isn't a function, okay? So let's do one now that is a function. Okay. Let's say we've got y equals x squared plus 1, okay? Y equals x squared plus 1. And I'm going to do the same thing. I'm going to choose some random number to plug in to this equation. I'll tell you, you don't have to worry much about the x value on this one. It's a quadratic. You just don't usually have to worry about them. But let's say we chose x equals 2 again. Why not? Okay. We plug it in. We get y equals 2 squared plus 1, right? Well, 2 squared is 4 plus 1. Y would be 5. Okay. And notice our input value, which is always our domain value of 2, gives us 1 and only 1 output value. Now look, that goes back to the original definition of a function. Functions are special relations in which the domain goes to 1 and only 1 range. The domain is going to 1 and only 1 range. Okay, it's just equationally showing that. Kind of neat. Okay, cool. So this is going to be a function. We've kind of shown it here, but I'm going to do the whole same rigmarole that I did earlier to graph this thing. So to graph this one, I'm just going to make a table. Okay, I know I didn't do it on the last one because there was a little more math involved, but I'm just going to make a table here, and we're going to do the input and output. So I kind of know how this one looks, so I'm kind of choosing the right inputs and outputs. But let's start at -2, -1, 0, 1, and 2. We've already got 2 already. It's 5. Okay. Now we're just going to think about this one. Okay. -2, if I plug that in, I square it, it becomes a +4, right? Plus 1, +5. Okay. This kind of tells me we have some sort of symmetry going on because the -2 and the +2 give me the same exact number. Let's plug -1 in. -1, you square it, it becomes a +1, right? Plus 1, 2. 0, I plug 0 in, I get +1. And I plug 1 in, 1 squared is 1 plus 1, I get 2. So yeah, again, I've got some symmetry going on because the same negative and positive values are giving me the same y values. Okay, opposite x values, same y values. So let's graph this now. See what it looks like. We're going to see this graph a lot this semester. Or this type of graph, I should say it that way. -2, +2, 1, 2, 3, 4, 5, 6. So -2, we're at +5. I'm sorry, yeah, that's right. -1, we're at +2. 0, we're at 1. And then 1, we're at 2. See how there's some symmetry here? And then 2, we're at 5. This thing is symmetric around the y-axis. Okay? Symmetric around the y-axis. I know it's hard to see. I mean, it's because I'm drawing this by hand. But this thing is symmetric on the y-axis. If I make the fold on the y-axis, we'd have it on both sides, right? But notice, if I do the vertical line test, no matter where I draw a vertical line here, it's only going to cross one time, okay? I could draw this wherever I wanted to, and it's only going to, you only have to do it once or find out if it fails once. This thing is definitely a function, okay? One input, or so you put in an input, you get one output, right? You graph it, yeah, definitely. And then if you made the bubbles, you'd see on these bubbles, they would go to one and only one output, okay? This is definitely a function. Yay, the crowd goes wild. Okay. Questions about this? Let's go over just a few, I'm going to just give you some few basic graphs just to determine if it's a function or not, because I want to come back to this equation. This is one of those things where I think the book does stuff just way out of order. Okay. So I'm going to graph some shapes, and we're just going to determine function or not a function. I want you to think about it at first, okay? Think about it. And we'll get this shape. Let's say like an oval. shape. So I'm drawing the axes first, yes. Let's say we've got like some sort of stock market thing going on. Up and down and up and down and up, something like that. And then let's just do a straight line. We haven't done one like that. Let's say we got a straight line like that. Okay, and then let's say we've got, this is called a square root graph. So it just starts here. And it just does that. And then, yeah, that'll be fine. Okay, let's look. I'm going to call these A, B, C, D, and E. Okay. Which one of these, and you can type it in there, Nicole or Brianna, if you're following, which one of these, and it could be more than one, are not functions. Okay. Which one are not functions? Think about it. Type it in. B, yeah, B is definitely not a function, right? I mean, it's a circle or if you do this right here, you see it crosses more than once. Is there another one that's not a function? No. Yeah, you're right. There's not another. The other 1, 2, 3, 4 are all functions, right? I mean, if I drew vertical lines on all of these, or kind of use my pencil and go across, you'll see that they all wind up only crossing once, right? So these are definitely the A, C, D, and E are all good examples of functions. Okay. So we're getting this, making sense. It's not that bad. I'll tell you, this section is not bad. It's really about notation we're going to use the rest of the semester. Okay. And the notation, which I'm about to go over, can get kind of goofy if you haven't seen it in a while. Now I'm going to go do something kind of goofy and write this right here. Notice we've got y equals x squared plus 1. And we determined that y equals x squared plus 1 is a function, right? We already determined that. Now, if we have an equation that turns out to be function, you can write it a function. Oh, I can't talk to it. If we have an equation that turns out to be a function, we can write this in function notation. And all function notation is showing that the y is now a function of x. That's what this means. Y is a function of x. So you'll hear it said as f of x. Now we can choose any letter we want. G of x, Q of x, whatever, J of x, doesn't matter, okay? The letter doesn't matter. Actually, typically it's used for notation. Like if we were talking about a revenue function, we'd call it R of x, right? F of x is the most common. So that's why you see it the most, because it's called a function, right? But I want you to understand that this just means that it's a function of x. And really, it's just a fancy way to say y, okay? So now here's the rules though. If we have a function, what that means is y can be by itself on the left-hand side, and we're going to write the y as f of x, okay? We're going to write the y as f of x. So now we have actually f of x equals x squared plus 1. And there's a lot of reasons we use this notation on a very basic level. It's because we can actually get the coordinate in the equation. I'm going to show you what I'm talking about now. If I wanted to find, let's say A, if x equals 7, what does y equal? Okay, I'm going to ask this a little differently here in a minute. But if x equals 7, what does y equal for this equation? Well, the way you would plug this in is you would actually say, well, if x equals 7, that means we're trying to find the y value when x equals 7. So f of 7, and it would equal 7 squared plus 1. F of 7. 7 squared is just 49, right? 49 plus 1 is 50. Okay? So on a very basic level, the reason we use this equation, or we use this notation, is that notice we have an equation here, f of 7 equals 50, but we have the coordinate 7, 50. So when x equals 7, y equals 50. It's kind of nice. So equationally, it pops out the coordinate. We don't have to do it in two separate ways, okay? We don't have to do it in two separate manners. Okay? So let's say B, I want you to find Actually, I'm going to see how the book asked this because I know they asked this question to get you kind of comfortable with the function notation. Oh, they asked it straight up. I'm going to ask you a little differently. So let's say, what about x equals 0? Now think about this. If I'm asking you to find x equals 0, I'm asking you to find the y-intercepts, right? Because remember, when the y-intercepts are when x equals 0. So let's do that one. So f of 0 equals, oh, we know this one already because we graphed it, but we get 0 squared plus 1. F of 0 just equals 1. So the coordinate would be 0, 1, right? The coordinate will be 0, 1. Kind of neat. So let's do some more. Now, I'm going to ask these now how your book is going to put them in. Your book's going to say, okay, well, what's f of negative 4? Okay, this is how the book's going to ask. What's f of negative 4? What that means is you're just going to say negative 4 equals negative 4 squared plus 1. That's 16, right? Plus 1. So f of negative 4 just equals 17. Because really, when we're using this function notation, we're not looking for coordinates, even though that's really what we have, right? Negative 4, 17 is the coordinate. What we're really looking for are solutions, okay? That's the solution to this function when x equals 4, okay? So a lot of different ways to kind of say the same thing, but it's all saying the same thing. Now, what's neat though is, let's say D, whatever you put inside there, you're just plugging it into the equation. Man, I wish I had a red pen here because I'm going to draw an apple. Well, I guess we've got a green apple. That's kind of a sad green apple. So if I asked you to find f of apple, you're just going to put in apple into the equation. Apple squared plus 1, okay? That's the answer. Or if I ask you, well, what's f of z? If it wasn't a number, right? What's f of z? Well, you just tell me that's z squared plus 1. We just change out the x for whatever's in there, okay? We change out the x for whatever's inside that function notation. Okay, so let's kick it up a little bit. And now I'm going to really just steal one from the book, okay? This is number, let's do number 28. 28 says, is giving you a function. This is on page 224, number 28. F of x equals 3x plus 7. And for part A, they want you to find f of 4. Part B, they want you to find f of x plus 1. I want you to try this. And if you get it wrong, it's fine. We're just going to try it. Part C is f of negative x. So try those three real fast. And we'll see what's up.
I don't know if I did that in the right format for that first one.
Oh, that's fine. We'll go over it. I'm going to go over it, Nicole. Yeah. Check this out. So for the first one, don't worry about putting it in the chat. The first one, we'd have 3 times 4 plus 7, right? 3 times 4 is 12 plus 7 is 19. Okay.
Oh, okay.
Does that make sense?
Yeah.
Okay. Now f of x plus 1 is a little different. You've got to replace x with x plus 1 here. So this is going to be 3 times x plus 1 plus 7. So we're not going to get a number like we did for the 4, and it's because our x value really changes, x plus 1. So I need you to distribute the 3, and I get 3x plus 3 plus 7. And I wind up with 3x plus 10. Okay, 3x plus 10. And then lastly, f of negative x, which we're going to see this in an upcoming section because it's important for something else. f of negative x, you'd have 3 times negative x plus 7. Well, you'd have negative 3x plus 7. Okay? Negative 3x plus 7. Okay, yeah. And again, this stuff isn't that, it's not that it's hard equationally, it's that we have to understand the notation. Remember I said that's the part that students have to struggle with at first with this function section is the notation. So I sit a little more longer probably than other faculty members on the function notation stuff, because in the past I've noticed students that kind of really understood the math but were struggling with the notation of everything. Okay? They were struggling with the notation. Okay. Make sure. Okay. Vertical line test. Talked about the function stuff. Sweet. Now we're going to get information from a graph, and this is going to be crucial over the next few sections. We're going to get some information from the graph. I'm going to just draw a graph, and then we're just going to get info from it. Okay. So, and we're going to use that interval notation that we talked about yesterday. So let's say I've got a graph, and I'm only going to deal with functions here, okay? Let's say I've got a graph, and I really need you to ask questions if something does not make sense here. I don't think it's a dumb question, please, because this is the kind of stuff that's going to snowball on us, okay? Let's say I've got a graph, and it's just kind of a stick, okay? Goes to -1 or -2, -1. We're going to have a closed circle here. And then it goes to 3, 2. But it's an open circle. So that's -2, -1. And this is 3, 2. Okay? 3, 2. I'm going to ask you a few questions. Actually, we're going to talk about the domain and range here. Okay. Remember, the domain, it's where your x values exist. Okay. Where the x values exist. So I need you to look at this graph. Remember, the x values are right here. Okay. The x values are this horizontal line. And if I think about this, look, let's say over here at 1, 2, 3, 4, 5, x equals 5. There's no y value for x equals 5, right? There's no coordinate that goes out this far to the right. You guys see that? And vice versa, like -3, there's no coordinate that goes out here to -3. That means our x values don't exist there. They don't start existing till -2 on the x right here. And then it goes over to +3 on the y. I'm sorry, +3 on the x. So from -2 to +3, our domain values exist. They don't exist like on 4 or 5 because the graph doesn't go that far to the right, right? They don't exist to -3 or -2 or -4 because they don't go that far to the left. Now, we got to think about this though. So our coordinates go from -2 to +3. Now look, we got a closed circle and an open circle. That means our x value exists at -2, so it's going to get a bracket. Remember we talked about the bracket meaning it exists there. So -2, it exists because it's a closed circle. Now +3 though, it gets infinitely close to 3, but it doesn't include it because it's an open circle. So 3 is going to get a parentheses. Okay, 3 is going to get a parenthesis.
Yeah, I have a question about that real quick. Why would technically B3 have a open circle?
I just made it.
Okay.
Yeah, I'm just making this up.
All right, I was just curious about that.
Yeah, no problem at all. Yeah, I just made it up. That's why it's got an open circle. Okay, so now let's look at the range. It's a good question, Nicole. I mean, in all honesty, that's a really good question. The range, let's look at the range though. So the range is going to go how far down to how far up. Now look at this one. Right here, it's -2, -1. So the range goes down to -1, but then it only goes up to this y value, +2. Okay? So it goes from -1 to +2, and we got the same issue. At -1, our range does exist. So it's going to get -1 there. But when we get up to +2, it's an open circle. So it's going to be a parentheses. Okay? It's going to be a parentheses. Okay? Questions about that one? I'm going to do a few more that are a little different, but the same idea. Okay? I'm going to give you a graph, and I want you to think, where's the domain? Where's the range? All that fun stuff. Okay? You know what? We'll call this graph A. So this was the domain for A. And then I'm going to draw another graph over here so I can just reuse the same piece of paper. I'm going to draw another graph here. Okay. Let's see here. Now this one's going to be a little different. This one's going to start at, let's say, -2, 2, closed circle. And it's going to kind of come down. It's going to go through the x-axis at, let's say, -1 here. It's going to keep going down. It's going to go down to, let's make it go down to 2, -2. Okay? Goes down to 2, -2, but then it goes back up. And here's what's different. It's going to go up forever. Okay? It's going to go up forever, kind of like a hook. But that arrow means this thing goes up forever. Forever, right? So same question though. So we'll call this graph B. Okay? B. Where do the x values exist? Okay, now think about this. The x values do stop over here to the left, right? If I think of my graph and I kind of followed along, it stops right here. So it stops at -2 again, but this time it's going to get a bracket. Okay, so -2 again. But then now because of that arrow, this graph would go forever to the right, right? It would keep going to infinity. And remember, because it's infinity, it gets a parentheses, okay? Because it's infinity, it gets a parentheses. And then now let's look at the range. Okay, so same thing, the range, it's going to go down to -2, right? Because that coordinate right there is -2 or 2, -2, right? So this goes down to -2, but then it goes up forever. I mean, think about this. This thing goes up forever because of that arrow. So it's also -2. That was just a goofy coincidence. I didn't think of that happening. Okay. This goes down to -2 and then up forever. Okay. Okay. Now I'm going to flip over to your book on page 225. And I'm going to steal one of the questions and we're going to answer it's got 6 or 7 parts here. Let's look. This is number. Okay. Domain, range, intercepts, y-intercept. Okay. Let's look at number. I'll do an even one. Let's do 84. 84, if I was going to graph it, so if you don't have your book yet, I'll graph this one for you. You need to get that book ASAP. Like yesterday, it needs to be in. Because we're going to be using it a lot from the homework. This is horribly non-straight lines, but that's not what matters. Our graph it starts at -1 here, -1, 0. It goes to +0, negative, or +1. And then this is actually called a square root graph. It goes like that. Okay. 2, 3. Okay. And we're going to look, if you're on page 225, the very bottom left there, it asks a lot of questions. It says A, what's the domain? Now I want you to do this one as I'm writing it and see if you can kind of get this. We'll check it. B is the range. C is the x-intercepts. D is the y-intercept. Okay. A, B, C, D, E, and the missing function. Now, the missing function for this one is f of 3. And we'll go over that. Try that real fast. I'm going to be right back. Oh, man, these are kicking in. Okay. Okay. Let's fill this one out and see if we've got it going on. The domain.
Right.
Now remember, the domain goes left to right. Okay. So if you think of this x-axis, it does not start existing till -1. And we exist there because it's a closed circle. And then it goes forever to the right, right? That arrow means it's going to go forever that way. So -1 to infinity, make sure to put a parenthesis around the infinity. Okay. Range, though, the range goes down. So think of it down to up. The range goes all the way down to 0 right here. It doesn't go below the x-axis. So it goes down to 0.
Oh, okay. I thought it. Okay.
You clicking now?
Yeah, I put the domain as -1 and then the range as infinity. So that makes a little bit more sense.
Yeah. Domain's always left to right. That's kind of the way you think of it. How far to the left, how far to the right. And range is how far down and how far up. Well, this this arrow is slanted up, so it's going to go up forever. Okay, we have to assume that it goes up forever. The x-intercept, though, now the x-intercept, it's where we cross the x-axis. It's right there, so it's -1, 0. Right, that's a coordinate. That's not an interval. I remember intercepts are written as coordinates, so -1, 0, and then the y-intercept would be 0, 1. It's right there, right? So there's the y-intercept. Here's your x-intercept. But then lastly, it asks you, what's f of 3? Now, this is definitely a function, right? That's a vertical line test. But so the question here, think about this. This 3 is actually the x value, right, for our coordinate. So if we go to x equals 3, we'll see it's harder to see on this graph, but in the book you can tell that the y value is 2. This coordinate here is 3, 2. So you get back 2, okay? So it's asking you really what this is asking is when x equals 3, what does y equal? And there's no equation here, so you can't plug it in. So you've got to just look at the graph and pull it off of the graph, okay? You have to pull it off of the graph. Okay, so now for homework, we've done, we've done this section now. For homework. Now, guys, this is going to sound like a lot of homework, but you have to realize a lot of this homework is just, is this a function, yes or no? Okay. So it's not going to take that long. It's a lot of yes, no, maybe, or not maybe, but it's yes or no questions. This is on page 224, section 2.1, 1 through 37. Then I want you to skip over to 55 through like 90. Yeah, 91. Well, actually, ooh, yeah, let's do 93. Nope, I lied. 91. So 1 through 37, and then 55 through 91. Okay, that'll be the homework for tomorrow. So get that done. Get as much of it done as you can, and then we'll go on to 2. Actually, I won't be here tomorrow. Remember that. So it's not that I'll go on to 2.2. The video I made last semester, earlier this semester, will cover 2.2 and I believe some of 2.6. Okay, I will see you all on Monday. Actually. Have
Okay.
a great weekend. Watch
You
the video